How do you restart it?
I can't do much.
I want to hear my voice though.
I can finish the level for him if he wants me to.
Okay, so we in the lecture we left off where we had some cross sections to do to find our volumes, and I was going to show you Prismoidal correction factor. And you guys were going to have a wee bit of a read of the lecture, seeing you couldn't see what I was reading, and just to familiarise yourself with what I was talking about. So, in a nutshell, this little diagram here shows us what we're talking about. So, for what we're going to do is we're going to draw our cross sections, which I showed you last week or the week before, last week I think. Cross section A is going to be looking that way, back up the hill. Cross section B, or you can do it the other way around, A and B, I don't care as long as you do these two views. This one here is going to look that way. So, just to be 100% clear, when we're doing this section across here, we are not going to be able to get it all the way so we can see the manhole over here. So forget that, we're going to have to do the squiggle I showed you last week to show the pipe is going to continue on. Don't forget to put the details on the manhole, copy it from your long section, invert level, bottom of manhole, lid level, etc. So when we're looking at this section here, we're going to, this part here, which is inclusive of the outlet structure, is going to be behind us. So if you remember when I was talking about the racing driver, anything behind you don't see, so you don't draw it, okay? So this piece here we won't see, but when it gets to that point right there, it cuts right through the pipe. Now that, I've only drawn this extremely roughly, it's not necessarily correct, but I'm just demonstrating that it'll be an oval. It'll be a bit like standing on a rugby ball, making it even longer and thinner, okay? And that will be determined by drawing some lines up from these 2 points, working out what the bottom is and the top is, and you'll end up with a square, rectangle, and you'll need to draw an ellipse. In the old days it was quite hard to find an ellipse on AutoCAD. Nowadays you just type in ELI and something comes up. Which is why a lot of people don't even do AutoCAD Classic anymore, they just start typing a command. We didn't have that advantage, but that's only something that's come in the last couple of years. It's a bit dangerous. Start typing in something, you think it's the right spelling, and you end up with another command. So that's one sectional view. This one here is really hard because the actual ground contours go almost parallel to the platform, so it's going to be very, very flat. So your best guess is what the ground is. If it's close to a contour, you're going to have to almost guesstimate exactly what the ground does. So this view looking that way back up the hill is going to be a bit odd. It's sort of going to be something like this, just with a little bit of fill. And some people might have done the contours a little bit wrong or whatever, and they might end up with a little bit of fill and a little bit of cup on them. So this might go on a slight angle. This one here, like I was saying, is, this one here is going to be kind of, the platform will look relatively normal. The platform will be sort of like that, but the pipe will be kind of odd. It'll be something like this, and then it'll be dashed going up like that because it goes up the hill. This pipe goes up at a constant grade, but that grade won't be equal to the grade on your long section. That grade will be worked out by drawing the level over here and drawing up to the level. It's a tricky one to work out. This one here is also tricky in terms of working out the levels. In terms of the butterfly wings, I've said to the other class that I'm not actually going to help you with the offset. So somehow you've got to work out what that is. So looking at a section through here, the diplomas have got a much better and easier pathway to working out their offset. Some have already done it. Basically, you've got a level here. You've got a contour coming through there. Well, let's make it a little bit further up. You've got a contour coming through here. And you've got a contour coming through here. And the level itself is a contour as well. So you actually know that level, you know that level. And what you've got to work out is what that distance there is. And what that distance there is. Because that's what the plan view is looking down on it. Which is what the offsets you're going to do from the platform. And unfortunately, like a lot of things in engineering, air tech and surveying, somebody smart in the class cracks it first and everybody else just follows like little lambs over the cliff. So in the test, this is an example of the type of thing. I will be going over these, but this is an example of what we'll be doing in the test. Although that looks very familiar, actually it won't be like that, it'll be like this. Distance, grade, 2 to 5, or 5.2. Level, 93.5. Distance, 10.8. What's that level? And it's no different than the maths required to do that. You guys have got 2 to 1 and 1 to 1. Right? So that's an example of, oops, I wish I didn't go hey bro in class, and because it's going to be 3 of them given to every student. Okay? So that's 3 marks for the diplomas, and whereas the offsets, in terms of the actual lines, drawing the offsets correctly is worth 2 marks. Which makes you wonder how I'm going to get 7 marks out of your proposed plan. Well, first of all, you're going to need a lot of those notes from that you all put all over your existing plan. So a lot of those notes will come through. And there are a number of other things, and the best thing that I can say to you is go back to where I drew over here on the whiteboard on week 2. So my job today is to talk about the prismoidal calculation sheet and how it all ties in with this. And I'll also tell you exactly how the marks work. So I think I did that in the lecture, but just in case I didn't, what you're required to do is a whole pile of little wee line drawings for sections. This one, the 2 black ones are going to have to be really good looking, just like your long section, right? You can't get out of that, they're worth 2 marks each, so you're going to have to do a reasonably good job on those. However, these ones here are going to look sort of something like this. And you only have to take the ground line a certain distance and that's it. This is all you need to draw in here. So you'll want the edge of the platform and you'll want where it meets the natural ground, which actually will be roughly that point there. So it's another way of drawing the butterfly wings or checking them off. When you get down here outside of your platform, sorry I'm a little bit rough here with my drawing. When you get outside of the platform, it becomes quite hard to do these sections because there's no platform. So they're going to be sort of like that, with a little bit of cut and a little bit of fill, or it might even be like that. So you don't have the platform itself in them. You choose this distance. A lot of students keep on emailing me, even though I've said it about 3 or 4 times. You guys have to choose that distance. I don't care if it's even, I don't care if it's not even. As a guide, it's somewhere between 1 and maybe 2. And you'll get about 7 or 8 of those. You'll find that when you start drawing these, remember you pick that up, you rotate it, and then you draw it up, lines up to do the sections. All you have to do once you've rotated it in the right place, just go copy, 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 and instead of coming up from that black line, which is where you're doing your section, you come up from that line, then that one, then that one. It gets quite quick. You get to a point where you can actually draw these things really, really quickly. There's about 8 of them. So by the time you've done 8, you'll be doing them quite fast. What I require is I require a number here, 0.98, 1.2, 0.84, but I also want the metres cubed. You only have to do that, squared I mean, you only have to do that once and copy it down. In fact, I would go XXX metres cubed, copy, 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 and then just edit it once you know the area. Now, if you've forgotten from last semester how to do an area, if you do a P line over here and leave it in the drawing, list it, it'll give you the area. The reason why I want you to leave it in the drawing is because I will list it and see if I get the same area as you. Okay, so that way I can check that you've been doing things right, and I can also try and leave this information in the drawing too, so I can have a quick look to see what you've been doing with your sections. It's so much easier to check someone that's left all their workings in the drawings than just nothing. So I don't want to see any of this in layout. I'll say that the second time. I don't want to see it in layout. Everything in model, that's your kind of playground. All I want to see in layout is once you've done all these numbers, so this side here is fill, this side here is cut. We have to put them into my spreadsheet. I'm going to show you that spreadsheet in a minute, and then you can etc. Then you can do a little class exercise if you want to. The answer's there already, and I'll show you how the spreadsheet works. And I want you to copy paste a piece of the spreadsheet right beside all your workings there. So this here is worth 1 mark, that's worth half a mark for the spreadsheet, which is pretty easy because all you're doing is putting those numbers into it and pasting it back into AutoCAD. The other half a mark I'm making you work for, that's the one where you have to summarise it in your notes, and you have to take into account the compaction factor. Now some people will find it too hard to draw this up here, so I'm suggesting maybe if you've left a little bit of the butterfly wing out there and there, you estimate the percentage. So not only have you got your compaction factor to deal with, but you may have to add on an estimated, I don't know, maybe this, as I've drawn that, that might be about, maybe if I take that and that, I think you'd be adding on maybe 5%, something 10%, something like that. But you're starting to get into the realms of estimating. The person that does it properly will have a much better and more accurate volume. These distances are important, don't lose them, and I'll show you where they go on my spreadsheet, and these are important. Otherwise, that's all you have to put in and it will pump out an answer for you. So that's pretty cool in that respect. I'll show you that now, and then that's the end of me talking. Sorry for those who like to listen to me for 2 hours, which is nobody. I'm going to then start walking around if you want any help. Go home if you want to keep working on your drawings, just, ask me questions and things. Okay? Yep.
We're starting to get a lot of layers. Is there any amount that you want us to not get to? Like, is there one that you'll get to and think, oh,
No,
that's crazy?
don't worry. The AutoCAD won't blow up. You can keep going.
No, but you looking at it and thinking it's too much.
If you want to make life easy for yourself, you can go existing plan, layer, contour. So you go existing plan and then put dash contour. Existing plan dash wetland, right? So when you're scanning down them, they'll be all under existing plan, long section, cross section, and you can very quickly go to the layer, right? So for your own sake, that's a really quick way of doing it. In industry, they tend to, on the left-hand side of your layer box, you can kind of break it up further if you want to, and you can go quickly to whatever you're working on. At the moment, I don't think it's that bad. It's just a bit of a scroll down to find the layer you're working on. Yeah. You'll be pleased to know I'm nearly halfway through the diplomas. That's pretty good going for me after 4 days. Do you know the average mark? Yeah, it's not too bad. It's probably, it depends if you want to take into account the ones that didn't hand in. They show as well. If you don't take the ones that didn't hand in, we're probably looking at around about 8 out of maybe 9 out of 15. Yeah. No.
How many?
But the person that got 5, you probably
8 out of 15.
Student have actually handed.
and the person who got 14.5 is
That
probably.
pass or?
No, 8 is
Just to be 100% clear on what I said in the lecture, I'm just about to show you the spreadsheet. I've 12 or more notes. The polar bearings around the traverse, and there was one other which I've just
You
forgotten.
handed in before Friday.
Handed in before Friday, yeah. So as an indication, I've marked half of them. Of those half, at least 3 handed in before Friday, the time. At least 4 so far have got the bonus for the traverse. And there's been about 4 as well with the bonus for the 12 notes. You can't get any more than half a mark out of that. So that's, there's been a couple that have got all 3, but that's the way it goes. It's a chance to get a half a mark bonus. All right?
So, but the 12 notes, I don't have 100 for Friday.
No, you don't have to have them all. Just one of those will score you a half a mark. But if you've got more than one, it doesn't add up. Yeah. But the other total on the right-hand side for answering a question in class, I think this gentleman did too, I think you have as well, that can't get taken off you, that is an extra bonus as well. So that's how it works. As far as negative marks go, I'm looking for mostly poor leaders, poor text heights, and one or two smallish things that Ingrid would have been upset about in terms of CAT as well. The docking of the viewport is not classed as poor CAD. Well, it is, but it's not because that's something new, and so that's at this level. So therefore, you just don't get your full 1 mark for the title block. And other things which are also classed as poor CAD issues, bad spelling, putting things on the wrong layer, presenting the drawing not in layout but in model space, or inside the viewport. That's even worse, because I've picked up drawings before where I've thought that I've been looking at layout space, but I haven't. They've left me inside the viewport, and I've been working away, and I'll go zoom extents and everything disappears because I'm in model space. I've gone inside the viewport, and because I've been zooming in and out, I've completely lost the scale and where the drawing was left. The only thing you can do is go undo right back to all the work you've been working on, or try and reset it. In the real world, we put our text and dimensions in paper space, so they have to match up with what's in the model. So it's not just about setting the scale. Yeah. Anyway, that's that. I'll just grab the spreadsheet. I'll go over it. For those that are not repeating this course, and it's first time round, this spreadsheet has got a number of columns, and I'll tell you how they all work. There will be 3 compulsory questions in the test on it. So it's important to know how the columns work and to remember it. In the test, I substitute the numbers for A, B, C, D, E, F, G, etc. And I will ask different students. Moodle will pick on you for a letter, and whatever that letter is, you'll be asked to put the number into the answer for the test. The calculations, you will have a long section which will have levels down the bottom, and you'll be asked to do some different calculations for those. You might be lucky, you might get the little, calculate the cut or calculate the fill. That's easy. That's the difference between the ground line and the formation level. You might be unlucky. You might have to calculate a grade based on not given a level, but given a distance or something like that. I'll go over a couple of those, but basically that's the calculations that would have been required to do your long section had you not have used CAD to do it. The little example I gave along there, I do a cut and a fill with grades and percentages, with grades, levels and distances, and it's not that hard mathematically, but you just have to get your head around it, which is the same as your platform and doing design contours. That's the second thing. The third thing is the prismoidal calculation sheet, which I'm going to go over. And lastly, there'll be an exercise on 2 spot heights and exactly what point here, 99 point north, does the contour cross, what distance is that? So anyone that did calculations will know exactly how to do that. So let's call that 99.45, and let's call that 98.78. Alright? And I will give you a distance there of 20 metres. So you have to calculate that. Yep.
So will it be like the same way we did it, divide the line and find the
No, not with nodes, not with AutoCAD, with calculator.
calculation?
Yeah. Remember I translated that into a long sectional view, a level here and a level here and a distance. So contours, design contours, prismoidal and a long section. And that will make up your somewhere between 10 and 12 marks of mathematical questions. Right? Not too many in the past. I mean, most I've taken this course with over 2,000 students over the last 15 years, and there hasn't been too many moan about the maths side of it. It's more the fact that they find the multi-choice quite difficult, even although it's straight from the notes. Okay. So yeah, I'll go over it. You'll have time. I think I do it in week 6. And week 7 is the test, all right? But don't miss that lecture because I'm not repeating it as such. I'll go over it on the board. Meanwhile, Roger keeps talking and he said he would. I'll get into Moodle and we'll get you guys rocking and rolling with the prismoidal.
It's not in the middle.
Did you sign it? Did you sign it? Did you sign it?
For example, if we submit it on Friday, before Friday, and then we keep updating on Saturday and Sunday, do we have any extra marks for it? Like Cassie says that if we submit it before Friday, we get extra half a mark for it. So if we keep updating on Saturday and Sunday, do we still get extra marks because we submit on Friday? No?
All right. So, right. So we have, some of you might be able to see through the dark, it's a little bit tricky, but we have the cross section
Can you see
here.
from this thing?
We have the distances here. So if you start down the bottom with say 0 and you work your way over here, that is the first column which we can't quite see. I will slide the bar along and you'll see its chainage. So the first column here is basically the chainage along the road. In this case it's a chainage along the platform. So that'll be up to you what those numbers are, and those numbers will determine these numbers, which is the interval. For someone that doesn't know what interval means, it's the difference between one chainage and the next one. Okay? So you can manually put those in from your cross sections, and the cut and the fill, these ones here, you can manually put in as well from these little numbers that you get when you do the areas each time. And guess what? That's it. You put those in, it'll just go brrr across there and give you a number here. If that's a negative number, it won't be fill, it'll be cut. It's a bit weird, it'll say negative something or other fill. Okay?
Yeah.
You'll all be different, obviously. The more decimal places, the more you'll be different. And you may need some, I think these have still got the same formula in them. So if you need more than 17, you can do that. Oh no, hold on, 11. You can do that. If you want less, just delete the rows. If you don't know how to do it, click on here, right click and go delete. And what we do is we highlight the end row, because this is the one that counts the most. This is the one I want to see in your model space. We right click and go copy or cut, no copy, and then we go into AutoCAD and go right click paste. You can also go Control C, Control V. So that goes here, beside everything in model space. I don't want to see it in a viewport. I just want to check that it's there. It will have different numbers for these. A lot of students think, oh, this is easy. I'll just do an Excel spreadsheet and I'll just copy these numbers in. No, those are the numbers on this side. They're the ones we start with. Remember I talked about the cubes and how we calculate the volume and how the prismoidal comes into play for correcting it? Well, this is the volume here. This is the old-fashioned 1930s way of doing it before this formula, where they started coming up with the formulas. This part here, adjust it. You'll notice those numbers are very close to these numbers, but they're slightly different and they all add up. If you added those two up, you'd get close but not the same. Okay? How does it work? I'm glad you asked me that. Average sum of the end area. Average sum of the end area. These two columns here under cut and under fill. What does it say out there in the formula? C9 plus C8 divided by 2. Well, that's pretty straightforward. That's C9, this one. So let's make that no fill. Plus C8 divided by 2, we'll make that one there. That one plus that one divided by 2. And I'll probably need to format that to say 4 decimal places, just at the moment. Quantities. Oh, by the way, if that was a fill, and we came here, that number would be equal to the previous one plus that one divided by 2. Now, if you know anything about Excel, I don't know if you guys have had any training in Excel over the years, but if you click on something, it up the top gives you a formula which tells you which cells, which cell number. So C9 would be that one there, and C8 would be this one here. And that's if it says divided, it'll have the divided. If it says multiplied, it'll have a star. And so you can come back and recheck this, but I'm just going over it for your sake. So the next one here is our quantities. Now the quantity, I'll do that in green. The quantity is equal to F13 times I13. So it'll be F13, which is this one, times I13, which is this one here. So we get the average sum of the end area and multiply it by the interval to get the quantity. Now, as I said before in my lecture, that used to be good enough. But then along came big diggers and trucks, and suddenly you're dealing with bigger numbers, and so therefore, if you got an error, it was more costly. And that's where we needed to bring in this thing here called the Prismoidal correction factor, and that gets calculated out of the end area ratio. Sounds complicated, it isn't. What it does is, as you go along the road, you get big areas of fill, little areas of fill, big areas of cut, little areas of cut. What happens with the end area ratio is it averages that out. So that if it's a big area, it suddenly goes, yeah, I know it's a big area here, but the ones before it were quite small, so let's not worry as much as we did when we were doing the normal calculation for these things. So that average then becomes an end area ratio, and then then they came up with the correction factor to apply to that. The correction factor is, I'll show you what it is. There's the formula. That's all you have to remember for the test. Why would I want to give it to you when I make you remember it? Okay, no, I'm not that mean, okay? Well, I am to the other class. This class is a very special class. So, yeah, you're all special. I'm going to let you guys have those numbers in the test. How about that? I know, I've done it to everybody, last 2,000 students.
One of these days, though, just one of these.
Yeah. You can't really say much to that at all. Okay, so you don't have to do that. But I will say one thing though, for those of you that are going to go on to surveying or engineers and use modelling programs, that is the mathematical formula that I was going on about, that the World Mathematical Champion has embedded into 12D, Civil 3D, MX Roads and Civil CAD, which are 4 main modelling